Okay, can you guys see the screen? Okay. Alright, let's begin. So the class is sequences in series, and this is the Algebra 2 slash Precalc class. And I'm your instructor, Shreyas. Okay. Arithmetic sequences. So an arithmetic sequence is a sequence of numbers such that the difference between two consecutive terms is constant throughout the series. So here's three examples. So there's 1, comma 2, comma 3, comma 4, comma 5, comma 6. You can see that 2 minus 1 is equal to 3 minus 2, which is equal to 4 minus 3, which is equal to 5 minus 4, so on. And then same thing you can notice here. It's just 4 minus 2 is equal to 6 minus 4, which is equal to 8 minus 6, so on. So that's basically what an arithmetic sequence is. So the common difference is D. So but by the common difference, I mean the difference between two consecutive terms. And the first term is A. The nth term will be A plus n minus 1 times D. Do you guys get that? Okay, so here's some examples. Given the arithmetic sequence -9, comma -5, comma -1, comma 3, comma 7, find the next three terms. So the common difference is +4. So the next three will be 11, 15, 19. And then here's another example. Given the arithmetic series or sequence, whatever. So 4, comma A, comma B, comma C, comma D, comma 18. Find A, comma B, comma C, comma D. So the first term is A. Even though it's 4, I'm just assuming it's some other variable. Let's just say X, okay? And then this is going to be X, 18 is going to be X plus 5D. So X is equal to 4, and X plus 5D is equal to 18. Then 5D is equal to 14, because you can just subtract both of them. So D is equal to 2.8, and you can easily find A, comma B, comma C, comma D from this. Okay, it's gonna get harder. I was just doing some review, so don't. Alright. Arithmetic series. So it's pretty much the same thing as sequences, but series are like a long list of terms. So it can have it could be like 10,000 terms or something. Sequences are normally a little bit shorter. So if you take the arithmetic series with n terms, a and then a plus d, a a plus d, and then a plus 2d, and you sum all of them, like you want to find their sum, right? So what you could do is you can write this in reverse order. So you do a plus d plus a plus 2d, and then you reverse it and you add that to the same thing. So you do a plus d plus a plus 2d, so on, plus a plus n minus 1 times d, right? So you add this and then you reverse it and add it again. And you're going to get 2a plus n minus 1 times d plus 2a times n minus 1 times d for n terms. So divide by 2 to get your sum, which will be n times 2a plus n minus 1 times d over 2. So that's the general sum for any arithmetic series. Yeah, but you don't really need. I mean, it's okay to memorize it, but I would just derive it myself. Just like quickly write it backwards. It's pretty easy. Just write the sequence backwards. Okay, so many of you guys probably know this formula for this sum of the first n integers, positive integers. Well, I'll just show it how you got that, how you get that. So it's saying find the sum of the first 100 positive integers. Okay, so I mean, you could be like so you could write it out as a plus 1, a plus 2, all the way to a plus n, and then write it backwards. Or you can just plug in your information into this. So you have 50 terms. You have 100 terms, sorry. You have 100 terms, so n is equal to 100, right? And your first term is 1. So it becomes 100 into 2a, or which is 2, plus 99d over 2, and d is 1. So you get 100 into 101 over 2. So you can generalize if you just plug in n is equal to, just let that be n. Clearly a is equal to 1 and d is equal to 1. Then it becomes n into 2 plus n minus 1 by 2, which is n into n plus 1 by 2. So we have shown that the sum of the first n positive integers can be written as n into n plus 1 by 2. Do you get that? Do you guys get this so far? Okay, so here's another example. Find all n such that 1 plus 2 plus 3 all the way to plus n divides 6n. So that means this sum, 6n divided by this sum, should be an integer. So using our new formula that we just found, you could say 6n over n into n plus 1 by 2 should be an integer, or 12n over n into n plus 1 should be an integer, or 12 over n plus 1 should be an integer. This is true for n is equal to 1, 2, 3, 5, 11. But do not put n is equal to 0 because the denominator would be 0, so the sum is technically not defined. So those are your n. Okay, here's another interesting sum. Find the sum of the first n positive and odd integers. So you can write it as 1 plus 3 plus 5 plus 7 all the way to plus 2n minus 1, right? If you reverse the sum, it's going to be 2n minus 1 plus 2n minus 3 plus 2n minus 5 all the way to plus 1. So you're going to get 2n plus 2n plus 2n n times. So your sum is just going to be 2n times n, right? Divided by 2 because you wrote the sum twice. So the sum of the first n positive odd integers is just n squared. Pretty easy. Okay, geometric sequences in series. So a geometric series is a series of numbers such that there is a common ratio between every two consecutive terms. So here's an example: 2, 4, 8, 16. 4 divided by 2 is equal to 8 divided by 4, which is equal to 16 divided by 8, which is equal to 2. Same thing with this sequence. The common ratio is 3. So the first term is a, and the common ratio is r. Then the nth term will be a times r to the power n minus 1. If you want to look at, if you want to find, oh yeah, sorry. If you look at like three terms, if you look at three consecutive terms in a geometric series, you notice that the middle term squared is equal to the product of the other two terms. If you look at this, right? A comma AR comma AR squared. So then A squared times R squared is equal to A times AR squared. So what this is said to also be the geometric mean of the two other numbers. So AR is the geometric mean of AR squared and A. Okay, summing geometric series. So if you have a series like 1 plus 2 plus 4 plus 8 plus 16 all the way to plus 2048, these are just the powers of 2, 2 to the power 0 all the way to 2 to the power 11. And you want to sum them, what you do is you multiply the series, right, by your common ratio in this case. So we multiply by 2, and you're going to get 2 plus 4 plus 8 plus all the way to 4096 is equal to 2s. If this sum is equal to s, this is equal to 2s. Subtract both series, and you're going to get 4095 is equal to s. So you can use a similar technique to generalize that the sum of n terms, the first n terms in a geometric series, with the first term a and a common ratio r, is a times 1 minus r to the n over 1 minus r. Or you can also write it as a times r to the n minus 1 over r minus 1. So that's the formula for the sum of the first n terms in a geometric series. So something you can do with geometric sums that you can't do with arithmetic sums is it's possible to find out the sum of infinite sums for geometric sums. but it only works if the common ratio is less than 1. So I'll show you what I mean. So if you have a sum like this, 1 plus half plus 1/4 plus 1/8 plus 1/16, and what you could do is you use this formula. A over 1 minus r is the sum. So what you do, your ratio is going to be half, and your first term is 1. So the sum is going to be 1 over 1 minus half, which is equal to 2. Yeah, and I talked about this. The formula only works if r is less than 1. Okay. So then there's repeating decimals. So this is also a geometric series topic. So you're asked, write what fraction does 0.127272727, forever equal. You could also write this as 0.127, and then the 27 has a line over it that indicates it's going to be repeating. So this fraction can also be said as 1 over 10 plus 2 over 100 plus 7 over 1000 plus 2 over 10,000. You guys get that, right? Like how I can write it as 1 over 10, 2 over 100. Yeah, so you want to find out what fraction does this equal. So if you essentially want to find the sum of all these terms. 1 over 10 plus 2 over 100 plus 7 over 1000 plus 2 over 10,000, so on. So what you can notice is that there's going to be an infinite geometric sum made with the terms 2 over 100, 2 over 10,000. It's going to go like 2 over, I don't know, like a million, so on. So that's kind of how it's going to become. So if you want to find out the sum of this infinite geometric sum with the 2 over 100 term, you can you can find out what the first term is, which is 2 over 100, your common ratio, which is 1 over 100. So your infinite sum will be 2a over 1 minus r, which is 2 over 100 over 99 over 100, which is 2 over 99. So now you know 2 over 100 plus 2 over 10,000 plus 2 over a million, so on, is 2 over 99. Then you can write out the sum for this. 7 over 1000 plus 7 over 100,000, so on. Your r is going to be equal to 1 over 100. Your first term is 7 over 1000. So your sum of all the 7 over 1000 terms and then 7 over 100,000 terms is going to be 7 over 990. So you want to find out, what is this equal? What is the sum of all of these? It's going to be 7 over 990 plus 2 over 99 plus 1 over 10. And you're going to get 7 over 55. So your fraction is 7 over 55. So this whole thing is equal to 7 over 55. You guys get that? The technique? Okay. So telescoping series. So this is kind of hard compared to what we were talking about before. So telescoping series look hard, but in reality they telescope. That's kind of why it's called telescoping. They telescope down to a really easy expression to solve. I should say to solve. To understand them, it's best to look at some examples. So there's three main type telescoping series I'm going to talk about. There's this one, and then there's this one. So the first example is find 1000 minus 998 plus 998 minus 996 plus 996 minus 994. You get it, right? And then all the way to 334 minus 332. So you want to sum that all. Yeah, so you guys get it. It's just like all the terms basically cancel out except for the last term, negative 332, and then the 1000. And then there's this one, 3 over 1 times 4 over 2 times 5 over 3 all the way to 40 over 38. again, all the terms basically cancel out except for the 40 times 39, and then the bottom two, 1 times 2. Yeah, so those are two easy type ones. Pretty easy. Okay, this is like one of the harder type ones, but if you just know the technique, it becomes easy. So it says find 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus all the way to 1 over 99 times 100. So what you can do is you want to generalize what 1 over n times n plus 1 is equal to. Because notice that all of these terms is essentially just can be written as 1 over n times n plus 1. Like this term can be written as 1 over 3 times 3 plus 1. This can be 1 over 2 times 2 plus 1, so on. So you notice that 1 over n times n plus 1 is equal to 1 over n minus 1 over n plus 1. Make sure to test this out so you know. So do you guys get why 1 over n times n plus 1 is equal to 1 over n minus 1 over n plus 1? Yeah, all these terms just become 1 over 1 minus half plus 1 half minus 1/3. It should say plus 1/3. Plus 1/3 minus 1/4 all the way down to 1 over 99 minus 1 over 100. So all the terms cancel out except for the first term and the last term. So your sum is just your sum is just 1 minus 1 over 100, which is 99 over 100. Okay. Then there's summation notation, which is used when you want to write the sum in a more compact manner. So if you want to find the sum of the first 10 integers, you would use this notation, which is called sigma. So you use the sigma notation, and on the top you write 10. On the bottom you'd write n is equal to 1 because that's where you're starting, and then next to it you would write n. So what it tells you is that your sum is just starting at n is equal to 1, and then it goes to n is equal to 2, then it goes to n is equal to 3, so on, all the way to n is equal to 10. So yeah, that's basically what it tells you. So then you just sum them all. That's what sigma notation tells you. So it's just going to be 1 plus 2 plus 3 plus 4 all the way to plus 10. Then there's another notation you can use, which I did not talk about. Wait, sorry. There's another notation you can use for like if you want to take the product instead of the sum. It's just like it just looks like 2 in Greek. That's all it is. A Roman numerals. Yeah, basically. Okay. I'm going to give you guys some problems now. Okay, here's your first problem. I'll give you guys 2 minutes to work on it. Okay, to make this more fun. Okay, wait, not excluding this question, because this question is kind of easy if you know the trick. Just the over 99 thing. So what I'm gonna do is like whoever types in the answer first gets a point. No, gets 3 points. Then the second person gets 2. Then the third person gets 1, and whoever has the most points in the end wins. Yeah. Okay, wait. Except for this question though, because this question's like. Okay, then get paper. I mean, this is like the only question you could probably do. And actually, one more. Okay, I'm just gonna discuss this. So, Yeah, there's two techniques to solve this. You probably have been taught, if it repeats, you can just do 72 over 99. But the way that people figure that out is because it's 7 over 10 plus 2 over 100 plus 7 over 1000, and it just repeats. So like, and so on, right? So then you can take the geometric series, you can like sum them, and you're just going to get 72 over 99, which is just 8 over 11. Easy. Yeah. Okay. Okay, here's the second problem. Okay, let's discuss this question. So, oops. So a over 1 minus r should be equal to 45. 45 times 1 minus r should be equal to a, right? Yeah, so I hope you guys learned a lesson. I told you guys were right. But you were wrong. I was waiting for you guys to realize. That's why I was taking so long. So the trick is do not copy the people above you because you do not know if they are right. I gave you guys like 5 more minutes to figure out if it was wrong. Yeah. So a is equal to 45 times 3 halves. Wow, that's kind of okay. It's okay. Yeah, you guys all have 0. Okay. So do not copy the people above you because you do not know if they're right. Okay, here's the next question. This one's going to be kind of hard compared to the other ones. The sum of an infinite geometric series is a positive number s, and the second term in the series is 1. What is the smallest possible value of s? This is 2016 AMC 10B number 16. Hint, look at the denominator of your sum. Okay, let's discuss it. Okay, so the sum is s and the second term is 1. So if you let your first term be, let's just say 1 over r, then the second term is going to be 1, then it's going to be r, and so on. That's kind of what I would do. And then you can use your infinite sum technique that we talked about, and you can write the sum as 1 over r divided by, wait, let's write this like this. Or this is also equal to 1 over r minus r squared. So you want to maximize the denominator since you want the smallest possible value. So you can use your this is, I think, an algebra topic, but like the vertex is essentially going to be the minimum. So the vertex is at minus b by 2a. So if your quadratic is negative r squared plus r, right, you're essentially, your x coordinate for your minimum is going to be negative 1 over negative 2. So this is half. So the minimum occurs at r is equal to half. So that just tells you that your series is 2 comma 1 comma half comma 1/4, so on. And that's just going to be 2 over half, which is equal to 4. So the answer is 4. Yeah, so 3 people got that one right, because only 3 people actually put in an answer. Okay, are you guys ready for the next one? Okay, here's the next one. Oh, whoa, 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 whoa. Wait. 1 second. What happened? I think number 4 just got eaten up somehow. Oh, well, I guess we're not doing a number 4. Okay, we're just going to go to number 5. Okay, here's number 5, I guess. Sorry about that. Yeah, you guys already saw this question. Okay. Okay, I'm just not going to count the scoreboard because there's technically only one question we actually did. So, yeah, this is like a math counts countdown type problem. Yeah, I remember this is, I think I did this question in a countdown, like in 7th grade. It was on the math counts countdown. Yeah, it was pretty easy. It was just like, who has it memorized? That was basically what it was. No, it was that chapter. It was the first question on the countdown round. Yeah, the Oakland chapter is just, it's just weird. Okay. Okay. Yeah, so the class is over. I'll teach my next class on Friday. Yeah. So bye. You guys can stay if you want, I guess. I don't know. I don't really care. Yeah, I'll send the slides. I'm gonna join the Google Classroom if you want to see it. All the slides. Do you guys have any more questions? I mean, we have like I can probably discuss like one question if you guys want me to or something. I don't know. Th- any question I can do in maybe like 10 minutes max.